Now, of course, your planning is only as good as your implementation. So where I'd like to go next is into the controlling side of the equation. So once we've defined a schedule that we can believe in, we've reviewed the risk. Now, let's assume that we've begun production. Let's do structural steel. Take a look at the steel erection. We're going to move into what we call control mode of the scheduling interface here. And let's say that we're working with superintendents on the job site. Every week they walk the site with the subs. The project engineers are out there walking the site. They're recording the actual work complete so that we can input this actual work complete back into the system and use it for forecasting. And the way we do that is by using the task control chart. Now, what you see here in the screen are our two steel erection activities. We have erect steel down here at the bottom, shakeout wind tack metal deck for our two activities here. And then each of the locations on the left-hand side has the start and finish dates that are currently in our scheduled plan. Now let's assume that we haven't seen any production yet. We intended to begin level 1, area 1 steel erection on the 14th. Go back down. So we're expecting to begin the steel erection on April 15th. If we set our date to, let's say, a week later, it's now April 22nd, and nothing has happened. This is represented in our schedule or in our control chart by a red box at that location, meaning the task has not begun and is running late. Again, it's the 22nd. We're supposed to be started on the 15th. We're supposed to have been finished with level 2 steel on April 22nd. And so we have these red boxes here. Now, let's say we've collected our weekly actuals. We actually did begin on the 15th, and we did finish on the 19th as planned for location A. We can input that start and finish date. The control chart updates, tells us that task is completed, green is good. However, red is still bad. And the reason that our level 2 location A is still red is because we were supposed to have started on April 19th, and it's now the 22nd. We don't have a start date on this activity yet. Let's assume that we actually did start on the 19th because we finished the previous location on the 19th. However, it's now the 22nd. We're supposed to be finished today, but we're not. The yellow box indicates that the task has begun, but is running late. And running late is what we want to look for in our forecast. So after inputting some actual data into our control chart, let's take a look at our forecast. And what you can see on the screen here, this bold line is our targeted activity for erect steel, and the dashed line is our forecast. Now, what this means is that based on the rate of production that we've seen over the past week, we're running behind on level 2A, and the program is forecasting, based on that production, a delay of 1 to 3 weeks to complete, to top out on steel. And of course, a delay in steel results in a delay in the successor activity of shakeout and wind tack metal deck. So what was originally planned on being finished before the first of the month, before for August now is projected to be completed on the week of the 15th. Now, this was only after 1 week. Obviously, it's a small sample size, but the function remains the same. That week after week, you're going to start collecting your actuals. The program is going to forecast based on those actuals. Let's say level 2 was actually completed the following Monday, not Friday. So it's now complete, but it did come in late. The following activity started on the 25th. It's not late. It's in progress. That's the blue box here. Because we're not to the 26th yet. We haven't input any actuals, but we were trending a little bit low. If we go back into our flow line and refresh the forecast, you can see that the trend is getting worse. We're still behind. It's a week later, and we're still behind where we were. And we're not talking about a 3-day delay now. We're talking about a month-and-a-half delay. And so this is when we might want to go back into the system, look at that. We're assigning 9 men to this task. And we probably, if we can, need to ramp up our steel production and make sure that we can put enough guys on this task to recover this time. Now, the one factor that we didn't consider yet is whether or not, we know we're not meeting production. We know we're not meeting planned production. But whether or not we're actually, the steel installer is actually showing up with 9 guys. That should be part of the weekly actuals tracking. So you're going to track your percent work complete, and you're going to track the men that are working. So the number of guys by activity can be tracked within the system as well. It's called a resource calendar. For erect steel, the current plan is to have 9 men on the job every day. However, if we're not seeing 9 men, we definitely need to get that input into the system, because if the program thinks we have 9 guys and we're getting slower than expected production, it thinks that the 9 men are not meeting the planned production rate. When in fact that could be caused by the fact that the steel installer is showing up with 7 men instead of 9. And so that could also be causing the delay in the forecast, but the production rate could be correct one. So these are all factors that you need to consider. Once you move into the slab on deck phase, you see we have these additional activities here and the matrix here. This can be printed out and taken to the field by the superintendent or by the project engineer. They can record the percent complete directly on this printout and feed it back to the person running the Vico office or the scheduling application in the office for their weekly actuals and updates. As a result of the inputting of the actuals, we can also produce reports, such as this completion report. Let me simplify this view a little bit, which would show us the targeted completion versus the actual. I've worked on the jobs I work on where we are tracking work for let's say the steel erection that we have here, where we're tracking it. We can produce a report like this on a weekly basis and send it up the chain to the superintendent or the project managers for their analysis. And what you can see here is on the left-hand side of this matrix, we have the target production, which is number of pieces of steel by location, expected production rate, In this case, we're in the 40s and up to 60. And then over on the right-hand side, we have our actuals. So if we take this first line item up here, we say that the production rate expected was 43.5 picks per day. What we were actually seeing is 36.3 in the actual production. With the overall impact in kind of a summary form of the schedule down here, the target degree of completion on this date is 7.4% for the project. The actual degree of completion is 5.9%, which is a difference of 1.6. And so this data can be used as a weekly projection of your actual production and can be used as a report to help make decisions about how to take action and recover any of the time that you were missing, or recover any of the delays that you're forecasting in the schedule. So that kind of is the way that we would move through the controlling portion once you establish your schedule. Again, just to summarize: plan, optimize, review that schedule in the 4D simulation to make sure that visually it makes sense. You can use that to communicate with both whether it's internally or to the owner, certainly to the subcontractors, both when when you're buying out the subcontractors and you want to communicate your plan, as well as using it as a look-ahead support in the field. And once you've actually begun tracking your actuals as part of the controlling phase, we can then go back into the 4D simulation and visualize the degree of completion and analyze the rate versus the plan. Again, the 4D simulation is really a great tool for helping to communicate the construction plan to everyone on site. It should be used anytime you're planning and optimizing a schedule, and anytime you might be looking at ways or opportunities to resequence the work as a result of maybe an unknown field condition, maybe a design change from the design team has caused you to kind of hold off work in one location. You have to resequence. And then, as we saw during this presentation, the opportunity to visually inspect the installation that's being planned in your schedule and look out for any location completion orders that may not be realistic or logical.